Hey guys, what is going on? It's your good buddy Sam. Hope you're doing well. I hope the infinite light and wisdom of Max and Pierre Boulez and computer music is shining down on you and your family and your children, etc., etc. What are we going to talk about today? Well, today I want to talk about. I was going through the package manager looking for some inspiration. And of course, it's not going to load because my internet is out. But the package that I want to talk about today is called Gibberwocky. Perhaps Gibberwocky, but definitely Gibberwocky. And what it basically is that's cool. When you have no internet, I guess this is what the package manager looks like. Gibberwocky is a text-based. It's a live coding environment. So you have a text document where you can edit patterns and sequences and stuff, and then send all that information to Max. So Max does your sound synthesis. This text file manages all your patterns and sequences. It's a lot of fun, and I want to show it to you with two caveats. The first, I'm far from an expert, so consider this maybe less of a tutorial and more of an exploratory journey that we're going on together. Two, it's definitely a work in progress, and there are a couple bugs, but the two people involved, I think there are only two people involved, Graham Wakefield and Charlie Roberts, are number one, incredibly nice and smart people, and number two, super willing to help. You can hit them up on Slack and, fix bugs together. That's the cool thing about open source software. When there's a bug, you hit the guy up on Slack, hit the man or woman up on Slack, and then you can it's a collaborative journey. So anyway, Gibberwocky. Once you install the Gibberwocky package, you'll be able to make a Gibberwocky object like this. And if you throw a button into your patch like this and bang on it, for a second there, you could see flashing up here the Amazon page for this Zojirushi rice cooker that I was looking at. Man, rice cooker technology, it blows my goddamn mind. Look at this. It has a sushi rice setting, a mixed rice setting, and a GABA brown rice setting that activates your rice, releasing its naturally occurring gamma aminobutyric acid before cooking it. Just unfreaking believable how powerful these machines have become. Probably sentient too. Probably will slowly take over your life and eventually come to dominate you with its greater than human intelligence. What are we talking about? We're talking about Gibberwocky, and what this Gibberwocky thing will do, let's go ahead and delete all this and I'll just show you. So try doing something like this. Okay, key commands you need to know. Control period stops all sequences. Control enter starts or sends whatever text you have highlighted to the engine or whatever, and that actually does the thing that you want to do. So one thing that we should do is save this patch. Let's save it as 73 Gibber. And you need to save it because Gibberwocky actually will do some synchronization between your Max patch and the this file here. And it only does that sync when you save the patch. So you need to save it in order to make that sync happen. But let's try doing something simple like this. Let's start with just Alice equals namespace Alice. And then having done that, I'm going to push Control Enter to send that line to the engine. And now if I click on scene, well, you won't actually see it here yet, but if I come to the patch and save, and then come back here, not yet. What if I just make a button, and then save, and then come back here? Will I see the namespace? No. Well, it'll show up there eventually, I'm sure. But I've made the namespace now, and now I can do something like this. I can do Alice dot hat dot seek, and then open up parentheses here and put in brackets 1, 2, 3, 4, and then add a comma and do 1 divided by 4. And this is going to play this sequence. Well, you can see, I think it's one of the coolest things about this Gibberwocky environment is that there's actually some, you can see that there's this outline around each text element as it goes through this sequence. I think that's super cool. And you can see that what it's doing is we've created this namespace Alice, and then under the prefix hat, we're sending out the sequence 1, 2, 3, 4, iterating through that once every every quarter of a second. or maybe a recorder note, I'm not sure. But anyway, the leftmost outlet of this gibberwocky thing, if you hook up to it now, you will see nothing until you turn on audio processing. And now you can see Alice, hat, 1, 2, 3, 4, those sequence dudes coming through here. If I do alice.moose.seek 5, 6, 7, 7, 8, 1/8, and power through, bang through that sequence. Now you can see we're going through this moose sequence twice as fast as the hat sequence. And we can do stuff like route Alice, and then route hat moose to see those two streams. Or this is how in practice you would separate those two streams, the stream of the first sequence and that other sequence. So that's one of the things that you can play around with in there. See, now the namespace Alice has showed up. I guess once I start this sequence, it's gonna make the namespace show up. Cool. So that's the one thing that namespaces do, or that's what one of the 4 things that you can control here with Gibber: devices, namespaces, parameters, and signals. Let's go a little deeper here, and I'll try to do something interesting. So using this hat sequence, let's just make let's make the shittiest analog hi-hat of all time. So just like noise, just really envelope noise, ADSR. Here's a neat tip for your ADSR. If you want an ADSR that basically you trigger and it'll just like a one-shot ADSR as opposed to one that has a sustain and a release, you can just make the sustain 0, but then you have to put in some release or it won't work. But now if I hook this up to a scope or something, hopefully you'll be able to see that this actually can generate like a one-shot sort of ramp. Anyway, I'm going to take that, multiply these two MFers together, and then if we throw in a gain tilde and an easy DAC, we should be able to hear some G-D noise. It's a little bit too long. Let's go down to like 200. It's fine. Could be a lot better, but totally fine. So now all we need to do is take the output of hat here, connect it to a button, and now... oh, no, not all we need to do. We need to actually send a number to ADSR. And I'm going to get rid of this moose sequence. So we'll do... this is actually kind of important. If you want to stop a sequence, you can't just do alice. This is one of the bugs that I kept running into. If you just do alice.moose.stop, you're going to run into a bad time. You actually have to do alice.moose_0.stop. Because when you do this alice.moose.seek thing like this, it creates a new sequence called moose with ID 0. There's an implied ID of 0. And so here, when you want to stop a particular sequence, you need to explicitly say that you're interested in the sequence under the name moose with ID 0 to stop it. I just push Control-Enter to stop it. So it's Control period will stop all sequences, and then Control-Enter will send a particular line through. So here I could say start this moose sequence, and then push Control-Enter to stop this moose sequence. Anyway, so let's get rid of that moose sequence and now mess with this hat sequence a little bit. I'm going to make it play once every 16, or play on 16th notes like this. And then instead of having a sequence of 1, 2, 3, 4 like this, I'm going to make it 1, 0, 1, 1. And then back in max here, instead of just taking anything that comes through hat and turning it into a bang, let's do something like this. Let's do cell 1 so that if we get a 0, we'll basically skip that note. And in this way, we can actually make kind of a pattern of those notes. We can go a little bit further. So say, for example, we don't want these all to have the same amplitude. It's a little bit annoying. Right now we're using the namespace, but let's use this params thing here. Probably a little bit hard to see in the YouTube video, but basically one thing you can do is if anything that has a scripting name in your max patch is something that Gibberwocky can pick up on and sequence from inside this text-based sequencer. So if I make a live.dial, for example, and then throw open this inspector, change the scripting name to hat_v, change the long name to hat_v, and the short name to hat_v. Now I can use this, for example, to control the velocity of this hi-hat. So if I do something like make an integer here to hold on to whatever number comes out of this live.dial, and then divide this by 127. This live.dial is going to be a number between 0 and 127, but the ADSR wants a number between 0 and 1. So in this way, this hat_v parameter, when it goes from 0 to 127, it's going to change the height of this envelope everywhere from 0 up to 1. So essentially, I can change the volume of this symbol using this parameter here. So I'm going to turn this back on and save it. And then if you look back here, now that I've saved, if you look back in the Gibberwocky context, there's a new parameter called hat_v. And if I click on it, it's going to enter this text params hat_v into the scene here, or whatever you want to call this space. So now I'm going to sequence this by doing the same thing as I did with this namespace. I'll do params hat_v.seq, and then let's do this. Let's do like 50, 60, 70, 80, 120, 1/16. And now, after I control enter that, it's sequencing this these different. Oh, I was like, why in the actual fuck is this thing not working? And it's because the DSP needs to be on, even to sequence control rate parameters like this. But now you can actually hear there's a little bit of change in the amplitude of this thing, which is kind of cool. One last thing we can do to add even a little bit more variety and potentially interest to this thing is I can come up to this, you can randomize a lot of these patterns as well. And now we're running very much up against the limit of my knowledge in this Gibberwocky environment. And I would have looked it up before making this video, but again, my internet isn't working. So one thing you can do is randomize these patterns. I'm going to come up to this hat_seq pattern here, throw in another 1 just for giggles, and then after this array here, I'm going to do .rnd, open up a parentheses here, and the first thing I'm going to put in is the number 1/16, and the next one is 2. And now, get ready for something that I'm very embarrassed to admit. I don't really know what either of these numbers do in this context. What I want is for every time this thing picks a new hi-hat value, for it actually to be randomized somewhere in so every time this thing is, as it steps through the sequence, rather than step through it linearly, the first and the next and the next and the next, it's jumping randomly through the sequence. And I know these two numbers are related to that somehow, but I'll be honest, for now, I actually don't know. But if we jump back over to Max, there's this like quasi-random pattern going on, which will be the basis of our beat or whatever. So like that's kind of it. Sky's the limit as far as this Gibberwocky thing is concerned. I think this noise here is pretty unsatisfying. So maybe if you want to stick around, we'll take it a little bit further. One final word of advice that I'll give to you is like, number one, this doesn't save. As far as I know, this text here doesn't save. And furthermore, if you click on demos over here and you try to open up one of these other demos, it will totally overwrite all this text here and it's just gone. You can't get it back, as far as I know. So get used to saving this to a separate text file, copying and pasting and all this kind of stuff. And hopefully, yeah, maybe that will change soon. I really don't know, but as far as I know, it doesn't save. Anyway, let's add a little kick drum to this. I'm just gonna take, well, first let's change this route hat moose to route hat kick. And then, seeing as we're making the crummiest cymbal of all time, we may as well make the crummiest kick drum of all time. So we'll just get, all you really need for a crummy little kick drum is a couple envelopes, one for the pitch envelope on your cycle. So basically you take a sine wave and just make it so that it pitches down as it plays. So after this ADSR, we'll do a scale tilde, like, I don't know, maybe from like 110 down to 55 or so. Might be pretty decent. This is hertz. And then we'll just multiply this ADSR by this. Multiply this ADSR by this cycle. And let's hear how this sounds really quick. If I throw a 1 in here, how does this sound? I'm dumb. This should be scale 1, 0, 1, 10, 55. Because this ADSR goes from 1 to 0, and I want the frequency of this cycle to sweep from 110 down to 55. Let's give this a listen. That's much better. Yeah, I can live with that. So let's give it the same treatment. Let's give this thing the same treatment we gave this thing. And just grab this nonsense, bring this over here, and just go like this. Need to change the scripting name of this guy from hat V. Let's call it kick V. Kick V. I called it kivk V. Kick V. And just go like this. Save this again. Okay, and now there's kick V, which is sick. So let's do alice.kick.seek. Just 1. I just want it always to play. 1 of 4. And let's do grams kickv.seek, and let's just randomize the velocity a little bit. So we'll do like 80 and 100, 80, 90, and 100. .rnd. Again, the numbers that I don't know what they do, and then we'll play a different one every quarter note. I wonder if no, it's worse. Cool, and now let's just add one last thing that's kind of interesting is that all of these parameters, so this adding this kick here after Alice just prepends this word kick. They all work that way except for one parameter, which is note. If I do alice.note.seek and then I do 0, 1, 2, 1, 2, 3, 1/16, and then enter that, what you'll see here, if I do route hat kick notes, and then let's make an integer box here and do some nonsense like this. What you'll see here is that as this thing goes, the number that's coming out here is going from 60 up to 65. So with all these other guys, whatever random prefix you happen to use, hat or kick or whatever, the particular prefix, or rather the particular number that you put in the sequence is going to be literally exactly what comes out in Max. But particularly for the note prefix or path or route or whatever, these numbers are going to be turned from automatically by Gibber from this number into a scale degree. So by default, it's C minor, I think. 60 is middle C, 60. Yeah, so it's C minor by default. I think 60, 62, 63, Yeah, that's C minor, or A major or whatever. Is that right? No. Whatever, C minor. Yeah, that's one thing just to be aware of with Note, is that it will automatically do these scale conversions. And there are facilities inside Gibberwocky for changing from one scale to another, changing the default scale of the whole set and stuff like that, which is kind of cool. But we're not going to go into that right now. Anyway, we've got these numbers here. Let's make a really simple little sequencer. And by sequencer, I mean synthesizer. ADSR 500, 0.200. Something like this. And then we'll throw this into a make note. And then I'll add a couple dials here. We'll call this one note V. It's going to be the note velocity. And we'll call this one note D. It's going to be the note duration. But note D, I probably want to go between, say, 5 and 500. Let's connect these up like this, and then throw these into a DDG mono, because we're just making a monophonic instrument. Send the frequencies through an or the MIDI pitch values rather, through a MIDI to frequency, and send the amplitudes to this ADSR. Multiply these two MFers together, and then let's hear the delicious sawtoothy result. Wow, apologies. This should be divided by 127. Sorry for that, which was 127 times louder than it should have been. What can we do to make this a bit more interesting? Let's start by just you know what, if we double up these saws, we can do a little phasing, which might sound cool. So let's do plus tilde, throw another saw in here, and then do like a cycle tilde. I don't want that, I want cycle tilde. Something like this. And let's add another thing here called like note P for the note phaser value. And this can go between 0 and 20, say. So this is just how deep this like phaser effect is. Here's none. And here's maximum. I'm going to save this, and now we should be able to just dork around with this and over here. So this sequence kind of sucks. Let's do like this. And of course you can jump between sequences just by like, so if I take this whole line, copy it, paste it, and then you just do Control P to stop, or Control period to stop everything. Anyway, so that's I guess a quick intro to some of the stuff you can do with Gibberwocky. I think it's super fun, and I'm really enjoying playing around with it. Maybe I'll definitely make a couple more videos talk about a bit more in depth some of the cool stuff that you can do. But in any case, thanks for watching. I hope that was useful, and yeah, I'll see you guys soon. Take it easy.